Hello everyone, today we will be solving a question from Statistics, Cambridge International A-Levels Exam, Statistics P7. Okay, so let's straight away dive into the question. So the first question says, the random variable x has the distribution b 10, 0.15. Find the probability that the mean of the random sample of 50 observations of x is greater than 1.4. Here given variable x, which has a binomial distribution with number of trials as 10 and the probability of success as 0.15. Now if we approximate to a normal distribution, we have two parameters that we require. So first one is the mu and the other is the variance. In this case, as the question is saying that we have to find the approximation for the discrete random variables of the mean, so in that case when we sample a mean, we have the mu for the normal distribution to be the same, but for the variance we will have to divide it by n. So as you know, in this question, n equals to 50 here. So how do we find the mean if we are given a binomial distribution? So we know that if you have a binomial distribution, mean is given by np. So in this case, if you put the value of n as 10 and p as 0.15, you get the mean to be 1.5, right? Similarly, we know that for a binomial distribution, the sigma square is npq. So if you want to find sigma square, then you just put in the values to get 1.275. Here you should know that q is just 1 minus p. Okay, so we've put the values of mu equals 1.5 and sigma square is this, where we approximate it to a normal distribution here. So when we put those values, we have 1.5 comma, the variance is this. Now if you have a random variables for the mean, it is when the mean follows a normal distribution, it'll have a mean as the distribution parameter as this. In this question, we are asked to find p where probability where mean has to be greater than 1.4. So as you know that the variable we took here was a discrete variable, so and also we know that the normal distribution is a continuous variable. So when we are approximating a discrete variable to a continuous variable, we have to do continuity correction. So then p mean has to be greater than or equals to this one, 1.4 plus this factor here. This factor here is the continuity correction term. Okay, and the continuity correction term is given by 1 divided by twice of n. So if you look at this carefully, you have px is greater than or equals to 1.41, and of course when you're solving a normal distribution problem, you have something called standardizing. Okay, if you standardize the normal distribution, you can find the answer or the solution by comparing it with the standard normal distribution table. Okay, now upon standardizing it, we get 0.5636, and this equals to 0.713. Now in this case, we have PZ is less than 0.5636, right? So in this case, oops, excuse me. So if you look at the first case here, you can see that this has a negative value, right? And this also has a greater than or equals to term here. So the probability that we are finding here is just finding the area of this one here. So this is minus 0.5636. So you're finding this area here. But by symmetry, you know that if I take this term this side here and find the less than area, this is also equals to this. Now this only happens for the normal distribution, as normal distribution is symmetric. So PC is less than 0.5636, so we looked at the table, normal distribution table, and then we have 0.713 as the answer. So I've given a reason here that if PC is greater than or equals to this, then this also implies it's equals to this. And this is the value that we have found here. Okay, that's for the question number 1. Now let's move on to the next question. Okay, so let's look at second question here. It's given in the question that the random variable x has the distribution n where the mean is 3.2 and the variance is 1.2 squared. The sum of 60 independent observations of x is denoted by s. Find p s greater than 200. Full stop. Okay, as you can see that it's given x has a normal distribution of 3.2 as a mean and 1.2 square as a variance. You could write it in this form here. Now this is a given thing, right? Now we also know that if we want to find the distribution of the mean, sampling of the mean, then if it is normally approximated, I mean like all the means, normally, I mean the random variable x here is a mean, right? So if it is normally approximated and we have a sample given to be 60, right? So if you want to find the mean of the normal distribution for the variable x bar, it's still going to be the same, and the variance has to be such that it's divided by n, variance divided by n. So because n is 60 here, small n, we divide it by 60. Now we also know that s is n times the x bar, right? So whatever the value of mean is here, that multiplied by n should give you the value of s. Okay, so here x1 is the value that we have to find, because we know that 200 is such that it's giving you the sum of s, right? Excuse me, sum of x. So as the sum is 200 and n is 60, right? N cannot change. So what should be the approximate value of the mean such that it gives you the sum to be 200? So the mean should be somewhere around 3.3333. Okay, so once we have done that, according to the question, what we have to do is we have to find the values now. So then probability of x bar greater than 3.333 is the same as saying PS is greater than 200, because this variable here, when converted in terms of mean gives you this. Now, when you standardize this thing here, we have z variable, right? So the standardized normal distribution will have mean as 0 and variance as 1. So you have the value of this one minus the mean divided by the standard deviation, right? So I have 1.2 divided by 60, but 60 I've already taken it upstairs. So, and there's a square root here, remember that, okay? Because as variance is given by 1.2 divided by 60, so this implies sigma has to be equals to 1.2 by 60, right? So this is just 1.2 divided by root 60. Okay, so this is the value of sigma that we have used here. So once we use that, and if you know how to do a normal distribution, this should follow straight away that this value of representation here simply means 1 minus pz is less than 0.8606. Okay, so if you want to do it from the if you want to draw the normal distribution this figure, you have something like this, right? So you have to find a value such that it's greater than this value here, 0.8606. So you have to find this area here. So this area is also same as saying this whole area minus less than. So that's what I've done here. So 1 minus PC is less than 0.8606. And comparing with the table, normal distribution table, you find that this value here is this, and hence the answer.